These massive airliners have crossed oceans and carried millions. But in aerospace, everything has an expiration date.
But this is not a graveyard. These grounded leviathans are built from the highest grade metal alloys on the planet. The journey of reincarnation begins with pure, unadulterated brute force.
Industrial surgeons use these massive hydraulic shears to bite with thousands of tons of crushing force. This is a rapid, strategic teardown. The thickest and most valuable aluminum alloys from the wings are severed first. Engines, landing gear, and wings are harvested, leaving behind the massive, hollow cylindrical shell of the fuselage. The skeleton and skin of the aircraft are then systematically chopped into large, transportable sections.
Loaded onto heavy transports, these pieces leave the silence of the desert behind, heading toward their fiery rebirth.
The massive, curved panels are dumped onto heavy-duty steel conveyor belts, feeding them into a terrifying mechanical maw. Powered by electric motors producing thousands of horsepower, the industrial mega shredder goes to work. In seconds, the panels that once sliced through the stratosphere are violently chewed into jagged, fist-sized fragments. But a modern airplane is a complex puzzle. To forge a perfect hydraulic cylinder, the factory requires a completely pure stream of material.
As the debris travels, powerful magnetic drums pull out all the ferrous metals, iron and steel fasteners.
But aluminum isn't magnetic. To extract it, a rapidly spinning eddy current separator creates a powerful induction field, violently repelling the valuable aluminum. It literally leaps off the belt into a dedicated collection bin. This creates a pure, segregated stream of high-grade aerospace alloy, ready to face the ultimate trial by fire. Now, the identity of the aircraft is entirely erased in a trial by fire. The pure aluminum fragments are transported into the heart of the foundry and fed into massive reverberatory furnaces. This is the Inferno. Temperatures here are pushed beyond 1,300 degrees Fahrenheit.
Inside the belly of the furnace, the solid metal rapidly breaks down, returning to its elemental, liquid state.
But melting is only half the battle. Impurities, known as dross, rise to the surface and are meticulously skimmed away. At this stage, metallurgists adjust the chemical recipe, adding specific elements to create a perfect, high-tensile alloy.
Once perfected, the furnace is tapped. A blindingly bright river of molten aluminum flows out.
It flows guided into a continuous casting machine, filling deep, water-cooled cylindrical molds.
Water jets cool the metal, solidifying it into long logs known as billets, the foundation of our hydraulic cylinders.
However, simply casting the metal is not enough. Cast aluminum has a random grain structure, which can hide microscopic weaknesses.
To survive the brutal life of a heavy-duty hydraulic system, the metal must be forged and manipulated under extreme pressure.
The solid billets are reheated in induction ovens, not to melt them, but to make them highly malleable, glowing a dull red.
The red-hot billet is loaded into a monstrous extrusion press, a machine capable of exerting thousands of tons of forward pressure. A massive steel ram strikes the back of the billet, forcing the softened aluminum through a specially shaped, hollow die. A massive steel ram strikes the back of the billet, forcing the softened aluminum through a specially shaped, hollow die.
It is exactly like squeezing toothpaste out of a tube, but on an epic, high-pressure industrial scale.
The metal emerges on the other side as a continuous, seamless, thick-walled tube.
This brutal extrusion process perfectly aligns the microscopic grain structure of the aluminum, giving the barrel incredible tensile strength, ensuring it will never rupture under extreme hydraulic loads. The raw extrusion is undeniably strong, but it is physically rough. It must now transition from a state of brute force into an object of extreme, microscopic precision. Inside the spotless CNC machining center, computer-controlled lathes turn the outside of the barrel to exact mathematical dimensions.
But the true magic of a hydraulic cylinder lies hidden inside.
The inner wall of the barrel must be flawlessly smooth. Even a microscopic scratch means a catastrophic leak.
Specialized deep-hole boring machines carve out the interior diameter with absolute, uncompromising accuracy.
Following the boring process, the barrel undergoes its most critical refinement, honing. A rotating head fitted with fine abrasive stones oscillates rapidly back and forth inside the tube. It polishes the inner wall until it gleams with a perfect, frictionless, mirror-like finish.
While the barrel is perfected, the heart of the system is being built nearby.
The piston rod is typically machined from high-yield steel, often recycled directly from the airplane's landing gear.
Because this rod will be constantly exposed to the elements, sliding in and out of the cylinder, it must be exceptionally tough.
After being perfectly machined, the steel rod is lowered into a series of electrified chemical baths. This is the hard chrome plating process. A microscopic, impenetrable layer of chromium binds to the steel. It gives the rod a super hard, frictionless surface. Meanwhile, the piston head itself is machined with deep, precise grooves.
These grooves are destined to hold the unsung heroes of the hydraulic world, the seals.
Automated machines, acting with delicate precision, stretch heavy-duty polyurethane seals and rubber O-rings, snapping them securely into place. These seals will tightly grip the mirror-finished barrel, trapping the fluid and converting liquid pressure into unstoppable mechanical force.
Finally, all the perfectly machined components converge in the spotless clean room assembly area. Contamination is the absolute enemy of hydraulics. A single grain of sand here could destroy a seal.
The piston and gleaming chrome rod are coated in specialized fluid and carefully guided into the honed barrel. Finally, the heavy-duty end caps, containing their own complex arrays of wiper seals to keep dirt out, are threaded onto the barrel.
Automated torque wrenches tighten the massive bolts to exact specifications. The cylinder is now complete. But before this reincarnated machine is allowed to leave the factory, it must prove its strength.
Every single unit is clamped into a heavily armored testing rig, and high-pressure hoses are locked onto its ports. Specialized hydraulic testing fluid is pumped inside. The pressure is cranked up far beyond what it will ever experience in the real world.
The massive rod extends, pushing with immense, unstoppable force against an immovable steel block.
Engineers watch the telemetry closely, looking for even a micromillimeter of structural bending or a single drop of leaking fluid.
A cylinder born from the bones of an aircraft must not fail. It holds firm. It has passed the ultimate test.
As a final mark of quality, a laser etches a unique serial number and the factory logo onto the gleaming aluminum barrel. Packed tightly into sturdy crates, these powerful cylinders are made ready to be shipped across the globe.
This is the beautiful, relentless cycle of industrial reincarnation.
The aerospace-grade metal that once soared at 30,000 feet was grounded, shredded, and thrown into the fire. But it was reborn, forged into the muscular arms of modern industry to power excavators, cranes, and heavy presses. From dominating the skies to shaping the earth, the journey of this metal is a stunning testament to the unstoppable power of recycling.